Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test, July 2025. In this video, we discuss the solution of a problem from the section Linear Algebra, and it is related to finding the largest eigenvalue of a given matrix. This question is placed in Part B, which is a multiple choice question, and it carries 3 marks. The question ID is 5629 54105. Further, this question is suitable for all these examinations. Right. The given question is: consider the real matrix capital A, which is given to be a 4 by 4 matrix whose first row is 29, 0, 55, 17. Second row is 1, 28, 46, 26. Third row is 17, 13, 33, 38. Fourth row is 21, 67, 0, 13. What is the largest real eigenvalue of the matrix A? We are given 4 options. Option 1, 101, 101, 101. Option 2, 67. Option 3, 103. Option 4, 113. Right. Look at the matrix and we check row sums. That means take the first row, add the entries the first row. That is row 1. That is 29 plus 0 plus 55 plus 17 is equal to 101. It is the row sum of the first row. Row sum of the second. That is 1 plus 28 plus 46 plus 26 is again 101. Row sum of the third row. That is 17 plus 3 plus 33 30 plus 38, that is 101. Row sum of the fourth row, that is 21 plus 67 plus 0 plus 13, that is equal to 101. What do we observe? We observe that each row sums to 101. That means the row sum of each row is 101. Right. Then what does it say? It says that the matrix A multiplied the column vector 1, 1, 1, 1, 4 column vector is equal to, when you multiply, you have seen the row sum is 101. So 101 column vector 101, 101, 101, 101. This is 101 times I4. This is like AX is equal to lambda x, where x is a non-zero vector. So that means to say 101 is an eigenvalue and the corresponding eigenvector is 111. So this tells us the 111, the column vector, is an eigenvector which is not equal to 0 corresponding to the eigenvalue 101. Thus we got one eigenvalue, that is 101. We continue in the next slide. Now we recall a definition for the spectral radius of the given square matrix. For any matrix A, square matrix A, the spectral radius rho of A, the spectral radius is denoted by rho of A. Here rho of A stands for spectral radius, not for the rank of the matrix A. It is defined as the maximum of mod lambda i's where the maximum is taken over all I. That means take all its eigenvalues, take the absolute values of all the eigenvalues, that is mod lambda 1, mod lambda 2, mod lambda 3, mod lambda 4, and take the maximum of all these things. That is the rank of, that is the spectral radius of A. That is the largest absolute value of eigenvalues. And the rho of A, the spectral radius, satisfies the following inequality. Rho of A is less than or equal to norm A infinity, where norm A infinity is the infinity norm of the matrix capital A. How it is defined? It is defined like this. It is, in other words, it is equal to the maximum row sum taking absolute values. The maximum row sum taking the absolute values. So, right. In our case, all the entries are non-negative. There is no need of taking the absolute values, and infinity norm, that is norm A infinity, is the maximum of all the row sums. And here in our case, every row sum is 101. The maximum of row sums is 101 only. So, thus the rho of A, the spectral radius, is less than or equal to norm A infinity, that is infinity norm of A, is 101. That means the rho of A is less than or equal to 101. What is the rho of A? The largest absolute value of the eigenvalues. The largest absolute value of the eigenvalues. So, the largest absolute value of the eigenvalues is less than or equal to 101. Therefore, the largest eigenvalue must be 101. Why? Because 101 is an eigenvalue which we have already seen, and no eigenvalue exceeds 101. No eigenvalue exceeds 101, and one of the eigenvalues is 101. Therefore, the largest eigenvalue must be 101. Be clear about it. The largest eigenvalue must be 101 because 101 is an eigenvalue of A, and rho of A less than or equal to 101 tells us no eigenvalue exceeds 101. But A has 101 as one of the eigenvalues, and hence the largest eigenvalue must be 101. So, let us look at our options. Our answer, the largest eigenvalue 101, appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. And it is not a difficult question. If you know the spectral radius of a matrix and the infinity norm and their relationship, if you know, in this case, this becomes easier. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like and share my videos with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, sir. I will definitely meet all of you in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.